Welcome. Let's talk about our second JTB here. And we've seen a little bit of this, so I'm just going to get going. This could be quick. I've got some errands I need to run, but you can always slow this down or repeat it. So we're going to find our first derivative, f prime x. I'm going to refer to 5x as our first function, e to the negative 2x our second function, and this is a product rule. So we need the first function, 5x, times the derivative of the second one. That would be e to the negative 2x times, treat the baby, negative 2. First function times second derivative plus first derivative, plain old 5, times the plain old first derivative 5 times the second function as it is. Okay. So we've got, clean this up a little bit, negative 10x e to the negative 2x plus 5e to the negative 2x. We're interested when that equals 0. I'm going to factor out, you can factor out a 5 or a negative 5. I'm going to factor out a negative 5 and an e to the negative 2x. And I get positive 2x. The 5's out, but I factored out a negative, so minus 1 equals 0. So when is a number times a number times a number 0 when either the first number is 0, negative 5 is never 0, e to the is never 0. So when is 2x minus 1 equals 0? When x equals 1/2. So I'm going to write down my y prime as the factored version. And that is equal to 0 at 1/2. So let's get our sign chart here. Put in a bigger value, say 10, something to the right of 1/2, and I get negative 5 on e to the negative, or on e to the 20th. That's a negative divided by a positive negative. When I multiply 10 here, I get 19. That's negative times positive negative. Or the graph is going down beyond 1/2. Let's put in a big negative like negative 10. Put in negative 10 and I get negative 5 times e to the 10th. That's negative. Put in negative 10, I get negative. Negative times negative, positive. So our graph goes up, it levels off, it comes down, we have a maximum. The coordinate of the x coordinate of the maximum is 1/2. This also tells us the graph increases from negative infinity until we get over to 1/2, because it never levels off again, and then it decreases from 1/2 forevermore because it never levels off again. And we are ready. Oh, by the way, it does not appear that we have a place for a minimum. We're ready for our second derivative. For the second derivative, I'm going to jump back up. Instead of the factored version, I'm going to use this. We could use the factored form, but I'm going to go ahead and say f double prime of x is negative 10x e to the negative 2x plus 5e to the negative 2x's derivative. First derivative's derivative, second derivative. First function, second function. I want the plain old first times derivative of the second, e to the negative 2x times negative 2, treat the baby. Plain old first times derivative of second plus derivative of first, negative 10 times the plain old second. So that takes care of this one. And now 5 e to the negative 2x is just plus 5. Derivative of e to the negative 2x is e to the negative 2x, treat the baby, times negative 2. Let's clean that up. I get 20x e to the negative 2x. Let's see, I get minus 10 e to the negative 2x, and here I get another minus 10 e to the negative 2x. So that gets me to 20x e to the negative 2x, and I've got minus 10 of these and minus 10 of these, minus 20 of these. And that is somewhat coincidental. You can trust me on that we have these 20s, but it makes the next step pretty easy. Factor out a 20. Factor out an e to the negative 2x, and we're left with an x and an x and a minus 1. And when is that 0? Only when x is 1. So I'm going to put 1 in relation to this 1/2 on my sign chart over here, and that's where the second derivative is 0, the second derivative being 20 e to the negative 2x times x minus 1. Okay, let's go big value, 10, something to the right of 1, positive. This stays positive, 10 minus 1 positive. Big negative, maybe negative 10, positive. Negative 10 in here makes this positive. Negative 10 here, though, makes it negative. Positive times negative, which means we are cupping down. That's our concavity. This is our slope. We're cupping down and then cupping up. So we have an inflection point, x coordinate of 1. We are concave up from 1 to infinity, concave down from negative infinity to 1. And we've got all of our answers here. Now we have to build the graph, and this is a little bit sneaky. So I'm going to use that information to build our graph. I'm going to put it right up here. And I can't resist, usually the simplest value would be if x equals 0, that leads us to the point 0, put in 0, 5 times 0 times e to the 0th, but times 0, 0. That's a point that's on the graph. Now from that point on, I'm not going to be too concerned with the y values. But let's take a look at end model behavior. We're considering what happens as we put big values into this function. And as I put big values into this function, say 10. 10's not even a big value, you understand that. But 10, I would get 50 on e to the positive 20th. Well, e to the positive, well, first off, it's positive divided by positive. We're going to be positive. But this 50 is not keeping up with e to the 20th at all, and it's going to get worse and worse, where this becomes relatively small compared to relatively huge. This is going to be approaching 0, which makes me feel like it's getting closer and closer and closer and closer to 0, which implies it is going down and cupping up. And let's take a look at the end model behavior right through here. The graph is going down but cupping up. And then I know interesting things happen at 1 and at 1/2. I go through 0, and we've learned that 1/2 is a maximum. I'm going to put it up here. I'm not putting a y scale, so just playing it safe. This might be a lot closer to the x-axis. Who knows? Maybe this is up at 100. I haven't given much thought to that. But I know that's a maximum, and at that maximum, look, we are cupping down. Well, that makes sense. And the cupping doesn't change until we get to 1, so I'm trying to emphasize this is still cupping down and then starts cupping up. After that, the graph is always going up, but always cupping down, which means it's getting steeper and steeper and steeper. And there we have a representation of the graph. Probably the very next thing we would want to do is find what f of 1/2 is. Probably put 1/2 into this function and see what we end up getting. But we have a nice global representation. We got the shape. We just don't really have a y scale built in. But it will look something like that. End model behavior, x equals 0. Consider end model behavior both directions. So I know that's very, very fast, but I wanted to get that out there for you so you'd have that tonight. That's what we're looking for, and we will practice this a little bit more prior to taking the JTB quiz. Thanks for checking in.